So I'm going to explain how to do problem 5. And I'm going to start with problem 4, which was just looking for the solution of how do I set up this triple integral with curved regions. And this is the surface to surface, curve to curve, number to number business. So the first thing is that we have to get very comfortable with the figure we're looking at. So if I look at this figure over here, I'm going to give it to you here. Here's figure 3. It was kind of difficult for me to get these labeled, but here what you're looking at is the z-axis. The x-axis, if I put a 0 down here, for some reason I started putting zeros inside my figure, but the x-axis, as I'm moving where my cursor's going, is from 0 to 1 on the x-axis, and this is from 0 to 1 on the y-axis. So I can actually rotate this around and see it. And what you're looking at is, if I tilt that upside down, I'm starting out on the elevator ground floor at z equals 0, and I'm popping out. So the surface to surface is the easiest direction to go to. So I'm coming out at the top, which is a plane. Let me rotate this. Probably making you dizzy. Rotate it back to where it was. So I can see that if I put a straight line in here, so let me see if I can put a straight line through here. I can't, so I guess I could on Desmos with some work. But if I put a straight line shooting from the bottom to the top, it would enter in at z equals 0 and exit out at the top, which was a plane. Then the shadow region, which I can actually see by turning this thing upside down, is this region down here, which I'm going to replot as a 2D picture on the XY plane. So let's go and look at that. The top and bottom surfaces in words turn out to be z equals 0, and the top surface is z equals this plane. That's what I just discussed. How do I get the next part of it? Well, I want to draw that region on the XY plane. So if I drew that bottom part here on the XY plane, I don't want to start tilting this thing again. It's upside down. The Y's are going downward. Let's see if I can do it this way. So you can see it. It's a little bit backwards because this is x is going from 0 to 1. So you're getting x equals y squared, which I picked up x equals y squared. This is the base. This is the shadow region. Unfortunately, I can't keep swinging that thing around. But my second integral, the easiest thing to do would be to shoot vertically first. So I enter in at y equals 0 and I exit out at y equals x squared. And then if I made a horizontal line on here, I would go from 0 to 1 on the x-axis. So that's how to set up the easiest of the 6 triple integrals. The bounds for here were 0 to x squared for the y and 0 to 1. Number to number is 0 to 1. So this triple integral comes together as this triple integral right here. Surface to surface is 0 to z equals 4 minus x minus y. Curve to curve is y equals 0 to y equals x squared. Number to number is x equals 0 to x equals 1. And just remember, triple integrals give you the volume with the function being 1. So that's the easiest one. Now let's say I wanted to now change the order of integration. Instead of dz dy dx, which is what I had. This is the one I had already solved. What if I want to change it to dz, dx, dy? Well, what's nice about this and why I would choose this one next, it's the same picture that I had before up here on the xy plane, because dz is taken care of by the first integral, surface to surface. But instead, this time, I'm going to be shooting this way first. If I shoot this way first, it enters in at that curve, and it's x. So it's going to be x equals square root of y, because I'm going to solve y equals x squared for x. And it exits out at x equals 1. I can see that. Enters in horizontally at x equals square root of y, exits out at x equals 1. So here I have a nice picture here I drew for you. You can see that horizontal pictures are entering in at x equals square root of y and exiting out at x equals 1. So I would get entering at x equals square root of y right here, this part, coming out at x equals 1. And then y would go from 0 to 1. I can see that from here. Y, that's where x equals 1 and x equals y equals x squared meet. It's at y equals 1. So the picture starts and stops at y equals 0 and to y equals 1 on the number to number. So that's my second triple integral. That's all I asked you to do here, because the rest of the math turns out very hectic. Now, how do I do that if I have to do that? Like, let's say I wanted to do dy first. To do dy first, I go back to this figure that I have, and I'm now going to have to figure out how to make it topped again. I'm going to rotate this. And I always shoot in the positive direction. So I have this figure, and my y in the positive direction is this way. Let's see if I can toss that so you can see it. We don't have the luxury of turning around figures, but here's my y's. I start here outside of the y, and I hit this wall if I pierce this shape. And so this is y equals 0 right here. This is y equals 1. If I go in and shoot an arrow through this from y equals 0 to y equals 1, it enters in at this wall over here, and it exits out at the skateboard curve kind of piece. So that wall, let me see if I can find the y equals 0 to see it. Yeah, here's that wall is y equals 0. Y is fixed to be 0, x and z are able to run. That's what forms that wall that I'm entering in. And it's capped on top by the skateboard region, which is y equals x squared. Y equals x squared is a surface. It's a surface in terms of y and x, and z is free to roam. What made the math hard is there's a caveat to this that sometimes I'm exiting out the plane. But I think that's good enough to understand what's going on. Like you're having two parts of it. This is the part of the integral I think is the easiest to understand. I have y equals 0 to y equals x squared coming as my upper and lower limits. I'm going to make another video going over the triple integral that you were asked to do 6 different directions for. That's actually got a lot easier math. And we're going to look at that picture because that's easier to look at. But that's what's going on here. What I do want you to be able to do on number 5 is I need you to be able to do switching from dzdydx to dzdxdy. You should understand that completely. Text me if you don't understand.